All right. So, you might, I mean, I'm sure all of you have seen this in your classes, basic circuit theory classes long while ago. And, apart from, giving you 2 marks in an exam, you might be wondering what is the earthly use of, I mean, it sounds like a cool theorem, but so what, right? Why is this? Why is this useful in practice? I will show you why it is useful in practice um, with an example. So, let us say I take, I don't know, some example toy network. So, why is reciprocity useful in practice? Okay. So, let me take some arbitrary network R1, R2, R3, R4, and let's say there was V1 here, there was a current source here called I1, another current source here called I2, a third current source here called I3, a fourth current source called I4, and have V out. All right. How will we find V out? What is the most straightforward thing to do? What is the first thing that that strikes you when I ask you to find V out? Very good. So, the first thing that comes to our mind is to say superposition. The straightforward approach is to basically say use superposition. So, and what does this entail? You de-energize all sources except one, and you find the transfer function from one source to the output, and you do this for all the sources that are there, right? So, how many times are you solving the network? In this particular case, you are solving the network equations how many times now? 1, 2, 3, 4, 5 times. Okay, and is therefore an inefficient of doing things. And why do I say it's an inefficient way of doing things? Because think about it. When you solve a network, when you say solve the network, what would you do? How do you plan on solving this? Pardon? Yeah, what is the mechanics of the process? You write KCL, KVL. You choose your favorite set of if you like mesh analysis, you do mesh analysis. If you do like node analysis, you do node analysis. But finally, you will end up doing the same thing over and over again 5 times with only a small change. Correct? Okay. The smart way of doing things is to use reciprocity, and the idea is the following. Well, we know that the transfer function from V1 to V out is the same if I instead injected let's say I injected a current source I here. What comment can you make about and measured the current I1 here, measured the voltage V1 here, the voltage, sorry, V1 must be in this orientation, V2 here, V3, V4. Okay. So, if you use reciprocity, what what do you think you can do? What conclusion can you draw regarding the transfer function from V out by V1 in this network must be the same as yes people, V1 by V out or V out by V1 in the network above is the same as I1 by I in the network below. Okay. Likewise, V out by I1 in the network above is the same as V out by I1 is the same as V1 by I, and so on. So, why is this a much smarter way of doing things? You solve the network only once, correct, and in one shot you are able to get all the transfer functions that you are after. And therefore, so this reciprocity therefore enables computation of multiple transfer functions in one shot without having to do the solution of nodal equations, one by one by one by one. Okay. And you might say, oh well, this is such a simple network, is it really such a big deal to solve the network 5 times? Why is there such a big fuss? It turns out that in practice, it's not uncommon for circuit designers to be dealing with transistors with, networks with 100 nodes, 200 nodes, where you have one output. And why do you have multiple inputs? It turns out, as we discussed in the very first class, every electronic device, it turns out, also adds noise. For instance, each of these resistors will add noise, which can be modeled, it turns out, by either a voltage source in series or by a current source in parallel with the resistor. And if you want to figure out how much noise there is at the output of a network, you need to find the transfer function from each of these sources to the output. Okay. So, this practical scenario where you need to compute several hundreds of transfer functions, right. In other words, transfer functions from several hundreds of sources to a single output, which would need, using a simple minded approach, would need several hundred evaluations of the same network where you are doing the same thing over and over again. If you use reciprocity, it is simply just evaluating the network once, and with this just one evaluation, you are now in a position to tell me what the transfer functions are from any source in the network to the out. Is this clear? Right. So, that is the one of the nice things about reciprocity. Now, you might argue, and however, there is one limitation, and what is that limitation? Pardon? What is the only, what is the limitation of, this obviously sounds like a great idea, right? Except that, it does not hold in networks that we are most interested in, namely, passive networks are great, but most of the time we are dealing with active networks, and active networks have control sources, correct? So, oh, this is all great, but it does not work for the real network that I am interested in, right? You understand? So, it is like finding, someone gave you like, a terabyte SSD drive, okay, to fix on your phone, except, you find out that the slot is of a different size, okay, and does not fit. So, all your plans of downloading like 400 movies is is now underwater.